Okay, so we are going to take a look at our notes, section 5-6, problem number 2, which is about area. We're going to look at the area of triangles. And I know what you're thinking. You're thinking, oh, we learned how to do area back in geometry or maybe even elementary school. And we use the formula, area is 1/2 base times height. And that is absolutely a magnificent formula. But we don't always have the height. In fact, we very seldom have the height. So today we're going to talk about 2 new ways of finding the area of a triangle. So one of the ways that we have is using what's called Hero's formula. The guy's name wasn't really Hero, it was Heron of Alexandria, but it's been abbreviated to Hero's formula. And Hero's formula looks like this. Area Now, this is sort of like the law of cosines. The first time you look at it, you think, oh my gosh, that's huge. It is so easy to use. The A, the little a, and the B and the C stand for the sides of the triangle. So in our problem, A is 12, B is 16, and C is 10. The S, which appears 1, 2, 3, 4 times in the formula, the S is the semi-perimeter of the triangle. Semi-perimeter is half the perimeter. Semi-perimeter is half the perimeter. So I'm going to find my perimeter by adding up all the sides. So 10 plus 12 plus 16 is 38. So the perimeter is 38, which means that the semi-perimeter is 19, half the perimeter. So to find my area, the big square root, I'm going to take 19, and then I'm going to do 19 minus 12, 19 minus 16, and 19 minus 10. 19 minus each side. Now, I did it in ABC order, but it truly doesn't matter. Just take 19 minus each side. So we end up with the square root of 19. 19 minus 12 is 7. 19 minus 16 is 3. And 19 minus 10 is 9. So now I take out my calculator. Remember, everything we do at this point is on the calculator. So 19 times 7 times 3 times 9. That's the square root of 3591. I just multiplied all these numbers together. Now I'm going to take the square root of it, and the area of the triangle is 59.92 units squared. I don't know what my unit is. I don't know if it's feet, inches, whatever, but I know area is always squared units. Remember to take the square root. You have second square root. So just second square root, 3591. And there you go. Wow. Easy peasy. Let's jump to problem D, because it is about the same thing. So the first thing we're going to do is find our perimeter, okay? So our triangle is 11, 15, and 17. I don't even really care about the letters for this problem. The perimeter is, what? Let's see, 30, 42. Check my arithmetic, does that look right? Oh no, 43. How's that? Is that better? 43? That's my perimeter. So what's my semi-perimeter then? My semi-perimeter will be half of 43, which is 21.5. So to find my area, using my formula here, I'm going to take that semi-perimeter, 21.5, and then I'm going to take that 21.5 minus each side. So 21.5 minus 11, 21.5 minus 15, and 21.5 minus 17. Now I know those numbers have decimals and everything else, but it's okay. You have a calculator. So let's figure out that's going to be square root of 21.5. All right, and then 21.5 minus 11. And 21.5 minus 15. And then 21.5 minus 17. Okie dokie. Now we'll multiply all those numbers together. So, and this time I get 6603.1875 when I multiply S times S minus each side. So there's 4 numbers under there. Got to have 4 numbers under that radical. And then I'll square root that. And my area is 81.26 square feet, square inches, square whatever unit happens to be in the problem. Hero's formula, super duper simple to use. All right, quick comment before we move on. I chose to do A and D first because they are appropriate for Hero's formula. And the reason they're appropriate for Hero's formula is because in the given, I have all 3 sides. That was the key. Because in order to do Hero's formula, you have to know the perimeter. And the perimeter is all the sides added up. So if you do not have all the sides, then you're not going to be doing the problem with Hero's formula. Okay, let's make a note of that. Hero's formula, if I know all 3 sides, then it's easy. Easy. Look at problem B, however. Problem B is not going to be a Hero's formula problem. Problem B does not have all 3 sides. So do you see how it would be impossible to do Hero's formula? You can't find the perimeter. So luckily, we have another area formula. Today we're getting 2 new formulas. One is Hero's formula, and the other one is 1/2 times side times side times sine of included angle. Okay? Now, when we say included angle, we mean the angle that's between the 2 sides. So, for example, in this triangle right here, problem number 2, 58 is in between the 10 and the 12. So that is called the included angle. If we had this side was 20 and this side was 30, this would be the included angle. The included angle is the angle that the sides make. All right? And that's the angle in this formula. So The area of this triangle will be 1/2, always 1/2, that's part of the formula. The first side, which is 10, times the second side, which is 12, times the sine of the angle in between them, which is 58. 1/2 side sine. So then I get my calculator out. 1/2 times 10 times 12 times sine 58 equals, and that is 50.88 units squared. I keep putting that unit squared in there because in a minute we're going to do some word problems, and we want to make sure, absolutely sure, that we are putting units on our word problems. So I'm kind of trying to get the habit right now. 1/2, 10 times 12 times sine 58. That formula is even easier to use than hero. Very, very simple. Let's look at problem C. That was B. Let's look at problem C. Remember, your job here is to find the area. So problem C looks like this. And I'm finding the area. Remember, 1/2 side times sine of included angle. We are home free. Area is, there's really no work to show. We go straight to the formula. 1/2 16 times 15 times sine 84. 1/2 side times sine of the angle in between. My area is 1/2 times 16 times 15 times sine 84 equals 119.34 units squared. So far, this has been like the easiest day ever. Hero's formula, very simple to use. 1/2 sine, very easy to use. Let's look at the last problem, problem E. Now, is this problem appropriate for hero? No, because in order to use hero's formula, I must know the perimeter. And if I want the perimeter, I must know all the sides. I don't, so I'm not going to use hero's formula. Okay, what about my 1/2 sine formula? Oh, wait a minute, stop. In order to use that formula, 1/2 sine, don't I need to know two sides? I do, and I don't. Well, what do you think I'm going to do? If you said find a side, you're right. I'm going to find a side. So let's see, this would be side B, and this would be side A over here. Looking at that triangle, don't I know that angle C is 69? Because the angles of a triangle add up to 180. And now, don't I have a pair? Which makes me immediately think of the law of sines. So sine 69 over 16 equals sine 49 over B. Now, I could have done sine 62 over A. It doesn't matter, I have to do one of them. So I do my pair for sure, 69 over 16. But then I get to pick, I just randomly picked B. I could also have done A, doesn't matter. So I'll cross multiply. And divide. So B equals 16 sine 49 over sine 69. that's side B, that's not an angle, so please don't be second signing this. This is just straight typing in. 16 sine 49, close parentheses, divided by sine 69 equals 12.93. So side B, if I typed it in right, comes out to be 12.93. Now I want you to look at what you just did. Now, do I have two sides? Yep. And do I have the angle in between them? Yep. So now I can find the area of my triangle. The area will be 1/2 side times sine of included angle. Now guys, if you're using this side and this side, then that is your angle. If you found side A and you're using these two sides, then that is your angle. You must always use the angle that's in between the sides that you are multiplying. So my area is 0.5 times 16 times 12.43 times sine 62. My area is 87.80 units squared. That one was a little harder to do because I had to find that side first. I had to do my lost signs to find that side. Okay? All right, now we're going to do the last section here. It's not really numbered, but it's page 43. We're going to draw a picture, write an equation, and solve. We're going to round off to the nearest 100. All right, so number one, find the area, that's what we've been doing. Find the area of a regular hexagon inscribed in a circle with a radius of 22 feet. So find the area of a regular hexagon inscribed in a circle with a radius of 22 feet. So here's a circle. A hexagon has 6 sides. So I am going to put 6 hash marks around my circle, and then I'm going to connect those hash marks, and that is my hexagon. Now I know it's not perfect, but that's okay. It's supposed to be all the same sides and whatever. I did my best. That's my hexagon. All that I know is that the radius of the circle, so in other words, go from the center to one of your hash marks, the radius of our circle is 22 feet. And my job is to find the area of that hexagon. So what I'm going to do is divide that hexagon up into 6 triangles. Now all those little segments I just drew are 22s. Okay? So all those little triangles, and again, my picture's not perfect by any means, but all those triangles are congruent. So if I could find the area of one of the triangles, then wouldn't the area of the hexagon just be 6 times the triangles? Whatever the area of the triangle is, 6 times that? So I want you to think about this for a second. There are 6 of these triangles right around here. All of these little angles right here are equal to each other. There are 6 of them. You see where I'm going with this? See? If there's 30 or if there's 360 degrees around this whole circle, and it's been divided up into 6 equal pieces, then isn't this angle 60? Because all the way around is 360, and we've cut it up into 6 pieces. Now look at this triangle. I have that side and that side, and I have the angle in between. So the area of my triangle is 1/2 side times side times sine of included angle. 1/2 side times side times sine of included angle. So that is 0.5 times 22 times 22 times sine 60. That's 209.58. But I didn't want that. That's the triangle. That's this right here. That's the area of the triangle. I don't want that. I want the whole hexagon. So I'm just going to take my calculator and hit times 6. Because isn't the hexagon 6 of those triangles? So I typed this in and then hit times 6. So my answer is 1257.47 square feet. Area is 1/2 side times side times sine of included angle. All right, number 2. We have a parallelogram. Okay, you got to remember what a parallelogram is. That's a parallelogram. One side is 14, one side is 16. That means this is 16 and this is 14. Opposite sides are congruent. And there are 2 angles here. There's this one and this one. That one is obviously smaller than that one. So it says the smaller angle is 48. And my job is to find the area. Well, think about what we did over there. We didn't really find the area of the hexagon, for we started out by splitting it up into triangles. We found the area of the triangle and then times it by 6. So I'm going to go ahead and draw in that segment, which is called a diagonal. And that's going to create 2 triangles that are equal to each other, because this angle is also 48. These 2 triangles are the same. Yeah, my picture's not too good, but these are the same. So the area of the triangle is 1/2 side times side times sine of included angle. So what will the parallelogram then be? The area of the parallelogram will be 2 times the triangle. If this is the triangle, then 2 times that will be the whole parallelogram. So 1/2 times 14 times 16 times sine 48. Now, I'll go ahead and write that down, but I don't need to write that down. That's the area of the triangle. I'm going to hit times 2, and there's my answer. 166.46 centimeters squared, so square centimeters. So those 2 problems were kind of similar in that we had a shape, and we had to find the area of it, so we split it up into triangles, and 1/2 side, 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 or 1/2 side, 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 and there we go. Now problem 3 is a little bit different. I've got the same parallelogram that I had a minute ago, but right, now I want to find the length of the longer diagonal. Now this purple segment is the longer diagonal. There are two diagonals. I drew this one over here, and then there's that one. I hope you can see that this one is going to be shorter than this one. This is the longer diagonal. All right? I'm not finding area, already did that. I am finding the length of that diagonal. Before I go any further, I need to remind you of two really important things about parallelograms. First of all, this diagonal does not cut this angle in half. So this angle gets cut, but it's not 24 and 24. That only happens in a rhombus. This isn't a rhombus. So don't make any assumptions, not 24s. Not sure what they are, but I know they're not 24s. Secondly, in any parallelogram, consecutive angles, that is angles right next to each other, are supplementary. So I automatically know, if they tell me that one's 48, I automatically know this one's 132. Supplementary means they add up to 180. If that's 48, that's 132. Done. Given, know it, no confusion, that's just it. So coming back over here, I know that's 132, because that was 48. Now, because that 48 got split, I'm going to go ahead and erase it for a minute. And in fact, I'm going to erase all of this because I want you only to look at that triangle. We are finding the length of a side of a triangle. We are not doing area. We are finding in problem 3 the length of a side. And you guys, there's two ways, actually, there's 3 ways to find the length of a side. You can use SOHCAHTOA if you have a right triangle. We don't. If you don't have a right triangle, then you're going to use either the law of sines or the law of cosines. That's it. Those are your options. Law of sines, law of cosines. This is not a sines problem because I do not have a pair. Remember, to use the law of sines, you gotta have a pair. You do not. So if I can't use the law of sines, I'm gonna have to use the law of cosines. So remember what that looks like. It's that big long equation. On this end over here, we're gonna have cosine 132. And clear over here, we're gonna have its side, which is x. So x squared. Remember, these bookend the problem. Whatever the angle is, that's on one end, cosine. And then on the other end, all by itself with the equals, is the side squared. And then in the middle, we have side squared plus side squared minus 2 side. There it is. That's your law of cosines, and that's what we use when we're finding a side of a triangle. So I'll type it in, 14 squared plus 16 squared minus 2 times 14 times 16 times cosine 132 equals, and then square root it. Remember, those of you that have the old calculators that don't copy and paste, use second square root, second answer. So second square root, you see your square root symbol right there, and then second answer, which is your minus, or not your minus, your negative sign. All right, and then equals. So the length of that diagonal is 27.42. 27.42, and my unit is centimeters, not square centimeters, because we're not finding area, we're finding length. Okay, finding the length. All right, one more, and then we're going to do a practice quiz to get ready for our next class. Okay, so here we go. Here we go. Last problem. Find the area of a regular pentagon inscribed in a circle. So I'm going to draw my circle. Pentagon means how many sides? 5. So I'm going to make 5 hash marks as evenly spaced as I can. Nobody's grading your picture. Don't worry about it. There's my pentagon. And I know the radius is 28. So if you recall, we did a minute ago, we did a hexagon problem. So if you recall, we're going to split that up. All these are 28s. You don't have to label all of them, for sure you don't. We're really interested in just one of the triangles. Now, this angle right here, it's not going to be the same as it was last time, but we're going to find it the same way. All the way around is 360. But this time, we've only split it up into 5 pieces. So 360 divided by 5 is 72. A revolution is 360. We've divided it up into 5 pieces. These are all 72s. Now, see this triangle right here? The area of the triangle is 1/2 28 times 28 times sine 72. I just erased it, but our area formula is 1/2 side times sine of included angle. So, that's my triangle. 1/2 times 28 times 28 times sine 72. That's my triangle. My pentagon, which is what I really want, is going to be 5 times my triangle. So I'm just going to hit times 5. And it's 1864.07 inches squared. There is the area of your pentagon. Okay. So let's see. I'll post the due date for that homework. We just finished 5-6. We're done. We're done with our notes actually. But we do need to do a practice quiz now, because our next class, we're going to have a quiz over 5.5. So here we go. Practice quiz 5.5. Directions say, solve triangle CHS. And then there's blanks over here, just like there will be on the test, or quiz, quiz, where you have to find everything that's missing. Now, I've told you this is over section 5.5. 5.5 is the law of sines, but you would know that anyway, because when you look at your given, don't you see this right here? That's your pair. That's going to be the law of sines. So sine 53 over 14 equals sine 62 over h, maybe? Now you might do things in a little different order, but this is okay. This is right. And we're going to get the same answer. So I'll cross multiply. solving for h, so I'm going to divide by sine 53. And that right there is what I'm going to type into my calculator. I'm going to type this in right here. 14 sine 62 close parentheses divided by sine 53. Side h is 15.48. Now, I need to find side s, so I'll start again with sine 53 over 14. Oh, wait a minute. I don't have angle s. Can I get angle s? Yep, because we know that the angles of a triangle add up to 180. So I got 65 for angle s. Did you? Hopefully. So now I can say sine 53 over 14 equals sine 65 over s. That's an s, not a 5. So s sine 53 equals 14 sine 65. I'm doing exactly what I did with side h. And the order you do these doesn't matter, so if you found side s first, fine, we should get the same answer. Divide by sine 60, or 53, sine 53. And type that in on my calculator, because that's s. 14 sine 65, close parentheses, divided by sine 53. I got 15.89. If there's something going on there that you're not sure about, that's when you come to office hours and get that figured out. Lost signs. And we knew it was going to be lost signs because of that right there. All right, one more problem and then we'll be done. Number 2, on the practice quiz. How many triangles are possible? All right, so let's look at this. This is triangle LKF. Guess whose initials those are? This is 14. This is 15. This is 63. All right. Directions are simply how many triangles are possible. So what do we know? We know either 0, 1, or 2. We also notice right here, we have the law of sines. Right? Right here. So I am going to set up my law of sines. Sine 63 over 15 equals sine k over 14. So 15 sine k equals 14 sine 63. Be careful, that whole thing is your variable, so you're going to divide by the 15. So sine k equals 14 sine 63 over 15. And then this is the kind, because you're trying to figure out angle k, this is the time that you have to second sign. Whenever you are trying to figure out an angle, you have to second sign. All right? So here we go. Second sign 14 sine 63 close parentheses divided by 15. 56.26. Now, think about when we did these in our notes. Remember doing the problems where we got error? If you get an error, when you type this in and you get an error, that means there are 0 triangles. We didn't get error though, we got an answer. So we immediately have to ask ourselves, could there be a second triangle? And remember, if there is a second triangle, that angle B, you just found angle B, or angle K. Where that came from, angle K. You just found angle K to be 56.26. The other angle K, if there is one, would be 180 minus that. It's always the supplement, so it's always 180 minus. So this would be 123.74. Now, is it possible for that angle to be 123? Is that possible? What happens when you add these two together? Aren't they already more than 180? So that isn't possible. And how many triangles do I have? Just this one. How many triangles are possible? One. One triangle. Remember, if this angle had been like 23, then this would be okay. Then I would have 2. But since it was 63, that's too much. That triangle won't work. All right, that's it. You guys are awesome.